Today we will learn how to create different components of an impeller. The components include the impeller itself, a bolt, a nut, and a shaft. Then in next session we will assemble those components to create the impeller. So here is the impeller that we are going to model today. Go to Annex, open a new file, set the units to inches, modeling environment, and here for the name, type impeller. Set the location where you want to save your file, click OK. Click on Sketch from the ribbon. XY plane is selected by default, click OK. Now you are directed to the graphic window. Click on Point from the sketching tools. Here in this dialog box, you can set your point. I'm going to create 2 points with the coordinates that I have. Click on this point dialog. The coordinates for the first point is 0, 0, 0 for x, y, z coordinates, so click OK. And here the point is created. Click on this point dialog once more. This time the coordinates are 11.75 inches, 6 inches, and 0. So x, y, z coordinates are entered. Press OK. Now the next point is also located here. Close the dialog box for point. Now I'm going to fix these 2 points. Move your cursor until it highlights. Right click and fix the point. The same for this point here. Move your cursor until the point is highlighted. Right click and fix the point. Now if you go back to the instruction, I'm going to create these 2 semicircles about those 2 points. So click on Arc from the sketching tools. Make sure this arc by center and endpoints is selected, not this one, arc by 3 points. So arc by center and endpoints is selected. Click on the origin, type 1.5, enter for the radius. And now you need to sweep to create the angle here. Move your cursor and sweep it to create this almost semicircle geometry here. Click once more. Now I'm going to create another arc about this point. While this arc by center and endpoints is active, click on this point. For the radius, type 0.5 inch, enter. Click here and create the semicircle here. Close the dialog box. Now I have these 2 arcs. I'm going to connect the top endpoints and the bottom endpoints. Click on arc again. Activate arc by 3 points. Now click on the endpoint on this arc and this endpoint on the other arc, and click once more somewhere between these 2 arcs, and do the same for the bottom endpoints. And click once more in the middle. Close the dialog box. Now I'm going to make sure that all these arcs are tangent to one another. So move your cursor until each of the arc turns to red. Now select this one. Now from the constraint, select tangent. Do the same for this curve and this curve. Make them tangents. select this arc, make them tangent, this arc, and this arc. Right click and click on tangent. Now all the curves are tangent to one another. If that tangent constraint doesn't show up, it means that they are already tangent and you don't need to tangent them. Now from the ribbon, click on rapid dimension, and here for the method, change it to radial. Now select this arc here and add the dimension. The radius for this arc should be 15 inches. And for this arc, click on this one, click once more here. The radius for this arc should be 18 inches. Close this rapid dimensioning dialog box. Now this is the sketch for our airfoil, and now we need to go to the 3D environment. So click on finish from the ribbon. Now we are in the 3D environment, and here, if there is no menu icon here, you need to click on this hammer, click on roll default, and here click on OK. Now the menu icon appears here. You can also click on this drop down menu and check view group, and all view tools appear here. Now click on menu, go to insert, go to design feature, and here select cone. The dialog box for cone appears here. Now first you need to select the vector, specify the vector. I'm going to create the cone in negative x direction. The point, click on point dialog. For x coordinate type 14, enter. For y and z, 0, 0, 0. Click on OK. Here you can see the method is diameters and height. Leave it like that, and now you need to enter the diameter for your cone and the height of your cone. So for the base diameter, I have 15 inches, type 15. For top diameter, I have 8 inches, and for the height of the cone, I have 16.25 inches. Leave Boolean as it is, and then apply. Close the dialog box. Now you need to select an icon which doesn't appear here. Go to this drop-down menu, go to View Group, and here if you scroll down, this See Through All. Make sure there's a check mark here, and now activate this icon here. Now you can see both the sketch and the cone. Now I'm going to extrude this airfoil in Z direction for 12 inches. Click on extrude, select the curve, set the vector in Z direction, Z coordinate axis, and for the end value type 12 inches. For Boolean, select Unite, and then apply. Close the dialog box, and here you can uncheck this C2 icon rotate your 3D model. So the airfoil and the cone are now united. I'm going to use the pattern feature to replicate this airfoil about the cone. Select the feature, select this airfoil here. For the layout, make sure it is circular. For the vector, activate specify vector, and then select XC. For the point, click on point dialog and set it as the origin of the coordinate system, 0, 0, 0, click OK. Here for spacing, select count and pitch. The count is 5 and the pitch angle is 72 degrees. So as you know, 72 multiplied by 5 is 360, which is the entire circle. Now the preview appears on the model that you can see here. Click apply. Close the dialog box. Now I'm going to create a hole on this face. You can create using the hole feature here, or you can draw a circle and extrude it. So I would click on sketch, select this front face, click OK, click on circle from sketching tools, start from the origin, and the radius for this circle is 1, and the diameter is 1 inch. Click on finish, click on extrude, you need to extrude in negative x direction and positive x direction, so reverse it. For Boolean command, select subtract, and here it should be subtracted for 0.5 inches. Click on apply, close the dialog box. Now you can hide this blue line here if you want. I'm going to sketch another circle on the bottom face. Click on circle, start from the origin. The diameter is 4 inches, enter, and finish. Click on extrude. This one should be subtracted in negative x direction, and the end distance for the limit is 16 inches. Subtract for Boolean. The preview shows that this is the right direction. Click on apply. Now again I'm going to get rid of this blue line here, hide it. So the impeller is modeled here. Save this file and go ahead with the next exercise, which we will create a boat. So click on File, New, Units are set to inches. For the name, type boat. Click on Sketch, XY plane. Now here I need a polygon. So from the sketching tools, if you click on this drop down menu, here make sure this more gallery is checked, and when this more gallery appears here, click on the drop down menu here and select this polygon. Here in this dialog box, you can set the number of sides for your polygon. We're going to create a hexagonal, a hexagon, so number of sides are 6. Specify point, click on this point dialog, 0, 0, 0, click OK. And now for the size, we have 3 different methods for creating a polygon. We have inscribed radius, circumscribed radius, and side length. Click on side length, and for the length, here type 0.246. So click on polygon, specify point, select this 0, 0, 0 coordinate. Number of side is 6, we're creating a hexagon. Here for the length, type 0.246. And as you move your cursor, so you can again type the length here, 0.246, enter. So as this dimension is very small, for rotation type 0, enter, and close the dialog box. So the hexagon is created. Now I'm going to extrude this hexagon. Click on finish, click on extrude. For specified vector, make sure it is in Z coordinate axis direction. For the end value, type point 1875 inches. Click on apply and close the dialog box. Now I'm going to create a sphere here. So again, go to menu, go to insert, design feature, and click on sphere. In the sphere dialog box, you have different options to create the sphere. Select this center point and diameter. For specify point, click on this point dialog, 0, 0, 0 for the coordinates of the point. Here for the diameter, you need to type point 57. 0.57 inches. And for the Boolean command, make sure that you select intersect. So this diameter should be 55, change it to 0.55 inches. And then apply. Close the dialog box. So if you go to Part Navigator, click on sphere, you can see that the sphere is here, but as we selected intersect, only the intersection between the previous model and this sphere appears here. Now I'm going to create a circle on this face, so click on Sketch, select the top face, OK, click on the circle, and the diameter is 0.38, enter. Finish. I'm going to extrude this circle, reverse the direction. Here for the end distance, type 0.001 inches. Boolean should be subtract, and then apply. Now again, if I get rid of this blue line, hide, you need to hide this. You see that there's a depth here. Now I have the cap for the bolt. I'm going to create a cylinder at the bottom. Go to Menu, Insert, Design Feature, Cylinder. Access diameter and height. This is the method that we use here for the cylinder. The direction for the cylinder is in Z direction, but negative Z. Now for the point 0, 0, 0, the origin of the coordinate system, click OK. Now you have to enter the dimensions for the cylinder. For the diameter, I have 0.25 inches, and for the height I have 1.5. For the Boolean, select Unite, and then apply. Close the dialog box. You can hide this one as well if you want. Now I'm going to treat this surface of the cylinder. Again, go to Menu, Insert, Design Feature, and activate Thread. Click on Detailed and select the surface of the cylinder. All the information will be included in this dialog box. Set the rotation right hand and then OK. Now we have a threaded surface on the cylinder of the bolt. Make sure to save this model and then go ahead with the next exercise. This time I'm going to model a knot. Type knot. Click on OK. Click on Sketch from the ribbon. XY plane as your datum plane. Again, you need to select polygon. The number of sides is 6. Here for the length, again side length from the methods. And here for the length, type 0.29. Or you can, and let's start it over. So activate this polygon. specify point as your origin. And now as you move your cursor, type 0.29 inches, enter, zoom in, and for rotation type 0, enter. Close the dialog box. Now I'm going to extrude this one similar to the previous one. Click on extrude. Vector is selected as Z coordinate axis, it's correct. For the end, select symmetric value. And here I'm going to extrude this for 0.125. Click on apply and close the dialog box. Again, I'm going to intersect a sphere here. Click on menu, insert, design feature, sphere. Center point and diameter, point dialog 0, 0, 0, click OK. For the Boolean, intersect should be selected. And for diameter, this time type 0.57. Then apply. Close the dialog box. Now from the part navigator, if you click on sphere, you can see the sphere. But in the model, we only have the intersection between the hexagonal body and the sphere. Now I'm going to create a simple hole in this knot. Click on sketch, select the top surface, click OK, select circle from the sketching tools, start from the origin. The hole has the diameter of 0.25 inches. Click on finish and subtract this circle. Click on extrude. Reverse the direction if needed. For the end value, through R. For the Boolean, select subtract and then apply. Hide the blue lines if you want. Now you need to chamfer this edge. Click on chamfer, select this edge here, and for the distance, it is a symmetric chamfer, and for the distance type 0.0436. Enter. Close the dialog box. So I didn't apply it. I would do this again. Click on chamfer, select this edge, 0.0436, and then apply. Close the dialog box, rotate the knot, and do the same for the bottom surface. Apply, closed. So the knot is also modeled here. Save this model and go ahead with the last exercise. Click on new, inches, and here type shaft. Set the location of your saved file. Click OK. Click on sketch, XY plane, OK. So click on Finish because this shaft will be modeled in the 3D environment rather than the 2D environment. So instead of sketching the geometry, I will start with the 3D environment. Go to Menu, go to Insert, Design Feature, and select Cylinder. Select Z-axis, positive Z coordinate axis as your vector. Specify point 0, 0, 0, OK. Now we have diameter and height for the method. For the diameter of this cylinder, type 4 inches, and for the height, type 18 inches. Apply, close the dialog box, and now if you right click, you can go to Orient View and select Isometric View. Now I'm going to add a cone on top of this cylinder. Go to Menu, Insert, Design Feature, Cone. Again, the direction would be positive Z-axis. The point, the starting point would be 0 for X coordinate, 0 for Y coordinate, and here 18 inches for Z coordinate. Okay, now you are back to the dialog box for the cone, and here you need to set the base diameter, top diameter, and the height. The base diameter for the cone would be 4 inches, the top diameter would be 6 inches, and the height is 10 inches. For the Boolean, select Unite, and then Apply. Again, right-click, go to Orient View, select Isometric. Or you can do this by clicking on Fit, and it will prepare a better view for you. Now I'm going to add another cylinder on top of the cone. Go to Menu, Insert, Design Feature, Cylinder. The vector is again Z-axis. The point, click on the dialog for the point and enter 0, 0, and for the Z coordinate, type 28. Click OK. Now again you need to enter the dimensions for the cylinder. The diameter is 6 and the height would be 20 inches. For the Boolean command, make sure it is Unite and then Apply. Again, click on Fit for Isometric View, and now you have this shaft that you can save. And after saving your files, make sure that you sign out from the remote desktop by clicking on Start, and here sign out. So thank you for listening, and that's it for this session. Next session we will assemble all these components for the impeller.